This is homework help file video for Math 107 for the homework over Chapter 5, and these are the problems in linear programming. So for linear programming, the biggest problem is writing out the constraints from the wording of the problem. You have to read it carefully. I've written this little table here to help you do that. So you have, it starts off actually with the objective function. Jack and Charlie can make $40 profit on skis and $30 profit on snowshoes, and obviously they want to maximize their profit. So the profit on the skis is 40, the profit on the snowshoes is 30. Okay. Now for Jack's time, he has a constraint of 500 hours that he can work. Charlie at 600. So the maximum time available is 500 here, 600 here, and then you look at how his work is divided up. 4 hours for the skis, 2 hours on the snowshoes for Jack. For Charlie, it is 3 and 6. All right, so now you have them grouped according to the constraint. Here's the constraint on Jack's time, here's the constraint on Charlie's time, and this will become the objective function. So with that information, you can write the constraint. It says the system has 4 constraints. 2 of them have to do with the fact that you cannot make negative numbers of skis or negative numbers of snowshoes. So at this point, we have to pick variables, and some people pick x and y, but then you have to remember what x and y means. It's better to pick some letters that are similar to the words you're talking about. Unfortunately, both of these begin with S, so you can't use the first letter, but I'll use K for skis and S for snowshoes. So the first constraint is that the number of skis you make has to be greater than or equal to 0, because you could make 0. You could decide not to make any skis or snowshoes. There you go. Those are 2 constraints. The other one is on the time that Jack has. So he spends 4 hours on every set of skis made. He spends 2 hours on every set of snowshoes, and he better not exceed the 500 available. So you see that's the first inequality. The second one, 3k plus 6s better be less than or equal to 600. So now we have a system of inequalities. I'm going to go ahead and write the objective function right here, and that's the profit. 40k plus 30s, and you want to maximize that. So this is your objective function. Usually the object is to maximize profit, but sometimes it's to minimize cost. And now we have to graph these to determine the feasibility region. Okay, so we're using the constraints. The first ones say that x and k have to be greater than or equal to 0, so that means we only have to work in the first quadrant. So you put your s here, your k up here, and now you look at each constraint and you find its s and k intercepts. The first one, let's do the first one for you. Whoops. 4k plus 2s has to be less than or equal to 500. So first we'll set k equal to 0, and that gives me 2s is less than or equal to 500, or s had better be less than or equal to 250. Take the outside number, and that will give you the edge. So here's 250. Okay, then you go back and you set s equal to 0. So when s is 0, you have 4k equals 500, k is 125. So I have another number here of 125 for the k-axis intercept, and I connect those 2 lines. Now, anytime I stay less than this, I'm going to satisfy Jack's time. Okay, then go back to the other equation, which was 3k plus 6s, 6 is less than or equal to 600. And you set k equal to 0 and find the s, right, which is 100, and then you set s equal to 0 and you find the k. And then you connect those 2 dots. Whoops. And as long as you stay less than this line, you satisfied Charlie's constraint. So going back, as long as I stay less than this line, you see this line, and in the double hatched region, I would have satisfied both Jack's constraint and Charlie's constraint. And that is a feasibility region. I need to know the corners of it. I know this corner. I know this corner. That's why you find those intercepts. I know this corner, which isn't too helpful, but it's also a corner. And I need to find that intercept. How do I find that one? I have to solve the two equations as though they were a system. Okay, the two equations were 4k plus 2s. And now you use inequality because you want to be right on that line. It's 500. And then it's 3k plus 6s equals 600. And now you solve this as a system. You can use substitution, you can use elimination, you can use matrices, whatever you want. You find the value of x and k where they intercept, and that will give you this value right there. Okay? And that's what it means. You also need to compute the point where the two time constraints intersect. And that would be this point right here. And now you have all your corners. And you can write the corners as ordered pairs. Obviously that's 0, 0. S of 0, 125. Then you'll have this point right here. And then you can also write this one, which would be 250. Whoops, no, it's 200. 0. Or maybe that's 100. At any rate, well, all right. Misinformation is better than... Is misinformation better than no information? There might be a hint in the misinformation. So, at any rate, you write down the corners, and there's 4 of them. This one, this one, this one, and this one. And you try out the objective function at each one of the corners, and you find out where it's maximum. And here's the second linear programming problem. I think you can work out this. I'll just give you a hint here. Here's the hint. What we're using, T and E, doesn't matter. This is in general. What we've done most of the time in class and up to now is have two time constraints that intersect. Just kind of sketch that over here. Here's my x. You would have one that goes like this, another constraint like that, and they intersect. And so the feasibility region is down here. It is also possible that you have something like this. Or maybe these aren't parallel lines. But the feasibility region is the biggest constraint. In other words, this really isn't constrained. This is truly the only constraint you have in your problem. So that's a possibility, and that's enough of a hint. I think you'll be able to do that one fine.